I'm going to talk about Agile testing challenges and how to overcome them. And I can tell you the first challenge is when you're in the testing space, you get asked by an organizer to do a presentation 3 days before the event, and you have to do it. So if you come here for fancy sort of slides and presentation, I'm sorry, it's just like black and white. Right, so Agile testing challenges and how to overcome them. Now, a lot of the talk I'm going to talk is about my challenges. So that's the agenda. A little bit about me, transition in dev and test, recap on the principles of Agile and testing, Agile development, what is a defect. Now, I promise you this is not a testing 101. Testing during development, Agile testing common challenges, and exploratory testing and test automation. And if we have time, we'll have like a few minutes just talk about testing in DevOps. So, just a little about me. Didnt Amido. I've been testing since 2004. I actually started my IT career in 2001 as a junior Java developer, and then I switched to testing in 2004. Now, there's a long history about it, behind it, why I switched from development to testing. And I founded testingexcellence.com in 2008, and if anyone knows about this site, you'll be invited to the 10-year anniversary in December. Just kidding. That's my Twitter handle. Now, it's not about testing Excel, Microsoft Excel. At the time when Twitter came about and I registered my Twitter handle, it allowed only a certain characters. So that's how much I could get in there. So testing Excel. I couldn't get the whole testing excellence. Now, transition in dev and test. The first time I came across this was in 2006. Why testing didn't find the defects in the waterfall V model. So typically when there was a production defect, a defect found in production, a serious issue, the managers would come to the testing team or test manager and ask why testing didn't find that particular defect. Come 2018, why testing is finding defects. Now, there's a shift in the mindset between how we used to think and how we used to think about testing and how we think about testing now. This is literally asking, why are we not doing it properly from the start? Why are we finding defects later on in the life cycle? Now, a little bit of recap, which I think the previous presenters already touched upon. In the waterfall V model, we had those sort of siloed teams, group of SMEs. So we had the developer team, we had the testing team, we had a marketing team, maybe a product owners team. Those things didn't exist that day. They used to call it something else. Now, in Agile, we have pods. We have like a group of people who are mostly T-shaped. T-shaped meaning they're specialized in one area, but they are they can understand, like for example, testers. They understand coding. They can at least read codes. They can speak the language of product owners. They know what's happening in the marketing. So they're not just focusing on like functional testing, for example. We had testing departments and test managers, whereas in Agile, we don't have testing teams. There is no QA team. There is no testing team. Testing is embedded in the Agile or in Scrum teams. And definitely no test managers. I wrote a lengthy blog about this, what's happened to the role of the test managers in my blog. If you want to have a read a little bit more about it, you're most welcome. So that's why I never actually pursued to become a test manager, because I knew it was a means to no end. The testing team and test managers were responsible for quality, whereas now the whole team are responsible for quality. The testers are testing whatever they can. Developers should be responsible for testing. Product owners should be responsible for testing. CIO, CEO, everybody should be responsible for testing. If you really care about your business, go and test the product. Now, I think this was touched upon in the previous presentation, defect detection and defect detection and reporting. Now, because testing was left at the last minute, the main aim was to find defects and have these huge sort of databases or bug tracking systems to log defects and sort of leave it for someone else to deal with it. And the test manager will hopefully pick up and go and discuss with the development manager that these are the bugs that are reported by the testing team and what are we going to do with them. Whereas here we're more focusing on defect prevention right from the beginning, because we don't have the time to find defects and fix them during the life cycle that we have in an agile development. And discussion. So instead of filing a bug report, you go and talk to the developer. Hey, I found this bug. Is it supposed to be this? Not just blindly, oh, it's not meeting the requirements, so I'm going to create a bug for it. Have a discussion. Maybe it's supposed to be like this, and somebody sort of had a different idea of how it was supposed to be implemented, and you had a different vision of how it should be working or it should be behaving. So discussion. In the waterfall model, we had lengthy test scripts and mostly manual tests. So you write, stepwise test scripts. Step 1, this is what I do. This is the expected result. This is the outcome. And you have a series of test scripts and heavy test strategies and test plans. Whereas in Agile, you're more focused on exploratory testing. Oh, this is touchscreen. No. And automated tests. So most of your regression tests you typically automate because, again, during the short cycle of an iteration, you don't have the time to test everything. And in the waterfall model, testing phase happened before the deployment to production, when the development was complete. Whereas now we are now testing throughout the development, and we go a little bit more on this and what it actually means. Now, I've been quite fortunate enough because, as I said, I started testing in 2004, and I've kind of gone through the different models of waterfall, V, Agile, and now DevOps. And all I'm going to tell you about is literally pure experience. There's nothing out of a textbook. These are all the challenges that I had faced throughout my projects, different companies, different people. So I'll be collecting your paychecks later. It's a very hard-earned experience. Right. So we do a bit of a recap on the principle. Now, once I went to an interview, and the interviewer asked me, what is your definition of testing? And now, software testing is a broad topic. It's a very broad topic, and it can't be summarized in one sentence. Various people, like James Bach and Michael Bolton, and other high-caliber people in the testing industry have come up with various definitions of testing. And I thought, okay, I'm going to give it my best shot in the time that I had. And this was my response. Now, testing is an activity to report that an implementation is fit for purpose and at the same time doesn't exhibit serious side effects. Now, this is like when you're checking for a requirement, you want to make sure that it's implemented correctly, and at the same time, it doesn't display, or it's not showing unwanted functionality or unwanted behaviors. to be honest, as testers or as developers or as implementers, we all have to accept that software will always have bugs. There is no escaping from that. No matter whether you're in waterfall, V-model, agile, it doesn't matter. There will always, as long, once I heard this fantastic line that the best software, the best code is the one that's not written, right? So the fact that you write a code, that means it's going to have defects. Now we go and ask, is it a tester or a QA? Now, has it ever occurred to you that within the agile context, people often refer to testers as QAs? So if you look at a typical job description, they say, oh, we need a QA for this team. They don't normally say testers anymore. They used to say testers or test engineers back in 2004, 2008. Now, they mostly refer to as QAs. And the reason for that is because we're not just limited to one activity. Like as QAs, we are supposed to test throughout the whole development. We are supposed to provide information to various stakeholders throughout the development and not just be focused on the last minute development or just the testing phase, which is, we don't have testing phase in Agile anyway, and we be reporting defects. That's not what QA is about. So testing is only a subset of the whole quality assurance practice. Now think of the Agile and DevOps. They're a set of practices. They're not roles. So we can't have a DevOps role. DevOps is a set of practices, is a culture. The same goes with quality assurance. Quality assurance is not a role. It's a set of practices. And now testing is an actual activity, whereas QA is a set of practices now, or principles. Now, where do we start QA? Where do we start testing? The whole essence of Agile is deliver working software frequently. If you sort of study the Agile Manifesto and why people are doing Agile development, is because they want to deliver working software more frequently. And in each sort of iteration, we increment on what we built on the previous sprint or iteration. And we do that iteratively. So each time we are incrementing the feature that we sort of supposed to deliver, and then we do that through a number of iterations. So incremental and iterative. Now, I highlighted the words working and frequently. How do we know it's working? How do we know the software that we built is working? We do that by getting feedback. And we want to get it by getting the feedback quickly. And this is normally done through automation. However, there's a whole topic about that later on. But typically, you want to get quick feedback. And frequently, how do we deliver software frequently? Because we want to deliver so frequently, we don't have time to find defects and then report to developer, and the developer go and fix, and then retest, and then he might have introduced another bug, and then go back and retest. So we want to prevent defects from getting into the system in the first place. Now, by the way, I studied chemistry at university, so I like to combine things. When you combine fast feedback and defect prevention, we get continuous testing. So continuous testing, so testing throughout the whole development. Now, we're going to talk about the fast feedback and defect prevention. In order to prevent defects, we have to know how the defect gets into the system in the first place, right? So think about it, right? You want to prevent something from happening, you know what that thing needs to be. So, what is a defect? Again, I gave it my best shot. This is my version of explaining what a defect is. Now, a defect is a bug as a result of a missed acceptance criteria or an erroneous implementation of a piece of functionality, right? So you either didn't implement the acceptance criteria or you implemented it wrongly. How does defects get into the system? The test scenario was not thought of, right? So you didn't actually, now this is the most important thing. So you didn't think about the scenario, right? During your refinement sessions or elaboration sessions, you didn't think of that particular scenario. So what are you going to do? The scenario was thought of, but was not scripted or tested. There is a bug in the test code itself, defect masking. So that means, like, for example, you expect the array to return 10 values, but because of the defect in the test code is reporting 9 or 11. And the software that you're testing also reports 9 or 11. So your test passes, but it's actually a wrong implementation. But because you had a defect in the test code itself, is masked. The defect is masked. And or the test code couldn't execute due to environment issues. Testing during development, what does it mean? I once built a house, not myself, but the house that we live in, we literally demolished it and we built it from scratch. And it occurred to me that, throughout this sort of development project, there are various people involved. And the key person is a building control who manages or who rather inspects the work of the developers throughout the whole development. Because once a building is built, you can't really see what beam was put across or what weight beam was put across. So you have to inspect it during the series of the development process. And this is what development through software is about. So you review unit tests as much as you can. Understand integration points, review architecture diagrams. Now, there are ways, you can find defects, and majority of the time is when you transition from one state to another. So by looking at the architectural diagrams, you have to sort of figure out what endpoints you are touching on your test scripts. Test branches before merging or merge and test frequently. Now, there's a whole sort of discussion around whether we should branch or whether we should commit to the master branch all the time. I'm not going to go into details, but that's a sort of, people have got different views on this. Test functionality at the API and service layer. Test usability at UI. Keep the UI tests just for UI. Don't test functionality at UI. Now, that largely depends how well your system is structured. If you have a SOA architecture system, you can test APIs for functionality, and you can test the whole system on the UI separately. Exploratory testing of new features, automated regression checking of existing functionality. I put a star here because automation is a very controversial topic, and it's one of my favorite topics. I'll sort of go into a little bit about this later. Test resiliency, ready for operation testing. Now, a lot of people, once they finish the functional testing, they forget about it. They give it to the TechOps or DevOps to do the deployment, and off it goes into production, and hey-ho, there's a bug. There's a serious bug. How are you going to find out? Test in production. And testing in production doesn't mean actually running your scripts in production. It means looking at the production service logs, looking at monitors and how, what is the memory usage? What are the traffic? Are we getting lost traffic in any particular page? Common challenges? These are my 5. Now, there are a lot of challenges, but these are my 5 sort of challenges that I faced in all of my testing roles, all of my companies, all of my projects. Not enough time for tests. Big enough sprint, write skeletons. I had a discussion with a friend over the weekend and said, what exactly do you do when a sprint starts and the development, you don't have anything to test because nothing's been developed yet? Well, write skeletons. Skeletons means reading the acceptance criteria, read requirements, understand the test, understand the context, what you want to test, and start scripting what you want to test. And later on, when it's there, feed in the details. Estimation should include testing effort. Now, I think that speaks for itself. Don't create testing subtasks because that creates development and testing. So developer says, I'm done with the development work. Testing is still left behind. You're only done when development and testing is finished, is done. Automate mundane, repetitive tasks. Take a risk-based approach. Now, all testing should be risk-based. I assume you all know what that means. Invest in exploratory testing, get the whole team to test. I'm afraid I don't have much time to go much into the details of this, but now the second common challenge is not enough details or poor acceptance criteria. The truth is that when a product owner writes a user story, he doesn't have a clear understanding of how it's going to behave. That's very rare that they have got 100% absolute clarity on what's going to or how it's going to behave. Don't wait for 100% acceptance criteria. Create test or develop on your understanding of the discussions you've had, because chances are that once a development starts, things will turn around. The product owner will look at it and say, not really, this is not what I really wanted, so let's change it to that. So the whole wasted time on writing automated tests or creating various apply common sense and apply common knowledge. These are the most valuable things. Now, again, this falls highly in the exploratory testing domain, but at the same time, you could also apply it to the story grooming sessions. Not reliable test environments. Again, one of the issues I had was the system was there, the system was built, but I had no working version of it anywhere because the deployment was wrong. It didn't happen, and I had to sort of build another environment or test locally. I can't stress the importance of getting the test environments. Get this right, and your whole development will be smooth, because development testing, it will just flow. Establish a test-infected culture. Now, as QAs, as testers, our responsibility is to ensure sort of the whole community that we want to create good product. And one of the challenges is to sort of make the testing acceptable by various people. But in order to do that, don't make testing a bottleneck, because nobody likes to see that software has been developed and it's been kind of halfly tested, but because it hasn't been approved by the QA, it can't go out. Don't make that mistake. Don't let the QA be the bottleneck. Run regular test batch sessions. Invite the whole company to test your application. You'll be surprised by how many observations they will report. Speak the language of business. Say how many critical scenarios you've automated, how many critical scenarios you've covered in your testing, and speak the language of developers. Expose your test. That means writing your test in the language that developers can understand, be it C#, Java, Ruby, Scala, whatever. Because once you do that, then the whole team understands what you're testing, and not just sort of, oh, he's got his tests somewhere else, I don't know what they're doing, and he only manages it, and let him deal with it. Not enough technical knowledge. Now, as QAs, again, one of the issues that we face is keeping up with the current sort of industry revolution in the testing domain. This is very important. Understand HTTP and API testing. A lot of the software nowadays is web-based. We have to know how the client-server model works. We have to know what is the request, what is the response, how the request is constructed, what is JSON, what is XML. Learn JavaScript for UI testing. Now, Java, C#, Ruby, Python, they had their days. Nowadays, a lot of the focus is on JavaScript. Learn JMeter, Gatlin. Those are the performance testing tools. Understand services offered by cloud platforms. We have to go through this very quickly. Two things that are very important in exploratory testing: test heuristics and test oracles. Now, if you haven't come across these two terms, do a research. Katrina Clokey is one of my sort of idols in the testing domain. Has written a really good blog post, but do a research on this. Test automation in Agile. Is automation really necessary? Now, I'm surprised that in this day and age, as I said, test automation is very controversial. So we spend a lot of, or the industry is spending too much money on test automation and not getting any value out of it. Now, this is largely due to not doing test automation properly, or doing test automation at the wrong layer, or trying to test automate everything. When you come to automation, it creates a narrow focus. So as an automator, you only focus on getting the test right, getting your script right. You tend to forget about all the different sort of scenarios that could happen while you're testing. Now, sometimes when they go through a story refinement session, they talk about, who is going to automate this? Is it going to be the developer? Is it going to be the QA? Or is it going to be someone else? The truth is that each layer presents different challenges. And the context is different. So at the unit layer, you catch developer mistakes. You can't find system defects. At the API test, you catch functional issues. You catch integration issues. At the automated UI tests, you catch usability issues, user journey issues. There are things which can't be tested at the unit test or at the API layer. So think about what you want to test and how it. Look at the bigger context of where this automated test or what it's trying to achieve. Of an automated test, acceptance criteria, user story. You either automate acceptance criteria, you automate user story, you automate a feature, or you automate an epic, which explains a user scenario or business case, or you can automate a customer journey workflows. Now, each of these, again, serve a different purpose. I wish I had more time to go into more detail on this, but that could probably be a separate talk for another meetup. Automate UI wisely. Look at the analytics. Look how the system is being used. Don't focus on some scenarios which is being sort of handled by 1% of users. I was once working at a travel firm company, and we were writing tests for creating a booking with 8 adults and 5 children and range of these children. But the truth of the matter is that only forms 0.001% of the users who are going to use that. Don't focus on the minority, focus on the majority. And apply good old testing techniques. If you've done ISTQB, which again is another controversial topic, you know what state transition testing is. Identify the entry points into the system. Look what the users or what features on that entry systems the users will interact with. See how the system will transition to another state. And pairwise technique. Again, that reduces number of your tests significantly, but at the same time it increases coverage. If you are going to write all of your automated tests on the UI, take this approach. Write shallow business scenarios, customer journeys that spans across the whole website, from homepage to confirmation page, for example. For each sort of page, have deep functional checks. So, for example, on the search results page, you will have a set of tests for filters, you have a set of tests for sort, you have a set of tests for pagination, you have a set of tests for change search, for example. Likewise, for product details page, again, booking page. Now, these ones should only be a handful, should only not be more than a handful of scenarios that span or exercise the whole system from like end to end, right? From the beginning to the end of the user journey. These ones focus more on the depth of each page. Now, I'm sure you've come across various shapes of test automation pyramids, test automation triangles, or ice cream cones. In the old days, we had monoliths where automation wasn't that sort of talked about. A lot of the testing was manual and largely done on the system or on the UI. Then we came across SOA, service-oriented architecture, where majority of the logic was pushed down to the service layer, and then somebody thought about inverting that triangle into this. So we have majority of the tests done at the unit layer, and then at the API layer, and some at the UI layer. However, these days, it's now this, because a lot of the logic is now gone into the client side. A lot of the logic is now done by JavaScript. So UI is no longer presentation of the data, which is presented by the API or by the service layer. So we have to have equal amount of tests across the unit, API, and the UI. Oh, by the way, Cypress. Has anyone heard of Cypress? Yeah. So Cypress is a kind of is a WebDriver so try to compete with WebDriver, and is mainly built for UI testing, which enforces developer, TDD, and Karate. Anyone heard of Karate?
Yeah.
No. Yeah? Good man. Good man. Karate is an amazing tool for API testing.
It works with Cucumber, right?
Yeah. But the guy who developed it is trying to trash Cucumber and have his own way of doing things. Thank you.